Hello friends, welcome back to my channel. In this video, I am going to solve exercise question from book Topics in Algebra from chapter 3 Ring Theory. Question is, if every x in R satisfies x square is equal to x, prove that R must be commutative. Now note that a ring R in which for every element x in R we have x square is equal to x, that is this condition is satisfied, then such ring R is said to be a Boolean ring. So here we want to show that if R is a Boolean ring, then R is commutative. So proof, R is a Boolean ring. So we have for every element x in R, x square is equal to x. Now note that if x square is equal to x for all x in R, and if we consider x square is equal to 0, then we must have x is equal to 0. That is additive identity of ring R. Now for any two elements, say xy in R, we have xy minus xyx is an element in ring R, since R is a ring. So using properties of ring, this will be again some element in ring R. Now we have for this element xy minus xyx in ring R, xy minus xyx square will be xy minus xyx multiplied by or dot xy minus xyx. Now solving this, we get xy dot this xy minus xyx minus xyx dot xy minus xyx. We get xy xy minus xy xyx minus xy x square y plus xy x square yx. Now in the next step, this x square will be x and this x square will be x, since x is an element of ring R. So we get this. Now here xy xy minus xy xy, these are inverses of each other, so they will give 0, and xy xyx xy xyx, these are inverses of each other, so they will give 0. So we get xy minus xyx square is equal to 0. Now because of this, and from here we can conclude that xy minus xyx will be equal to 0, and therefore xy will be equal to xyx. We will call this as number 1. Next, similarly for xy elements in ring R, yx minus xyx will be again some element in ring R, and yx minus xyx square will be equal to yx minus xyx dot yx minus xyx. Again solving this, yx dot yx minus xyx minus xyx dot yx minus xyx will give yx minus yx square yx minus xy xyx plus xy x square yx. Again in this step, replacing this x square and this x square by x, we get yx minus yx minus xy xyx plus xy xyx. Now these are inverses of each other, so they will give 0. Similarly, these are inverses of each other, so they will give 0. So overall we get yx minus xyx square is equal to 0, and therefore we have yx minus xyx should be equal to 0, and therefore yx is equal to xyx. We will call this expression as 2. Now from expression 1, that is xy equal to xyx, and from expression 2, that is yx equal to xyx, since their RHS are same, we must have LHS should be same, and therefore from 1 and 2 we have xy is equal to yx. Now since xy are any arbitrary element of ring R, and we get xy equal to yx for all these arbitrary elements, we must have our ring R should be a commutative ring, and this proves that if R is a Boolean ring, then R is a commutative ring, and this proves our result.